Okay, so we're taking a look here at um, item 20 from the 2016 Excellence in Mathematics competition. And we're going to show that now okay, so let's read through this first. Two right triangles, both with legs measuring A and B, where A is greater than B, are overlapping as in the image. What is the area of the gray quadrilateral? And really the quadrilateral here is blue, I suppose. But we're going to show that this area is equal to AB squared over A plus B. Okay? Now, because there are no numerical values here, it's really hard. There are some that you can do. It would be really difficult, in this case impossible, for us to solve this problem numerically or to give a numerical answer. So we're going to show that it's this algebraic representation. And we're going to start by, so, like I've said before, there are multiple problems or ways to solve a problem. We're going to look at this one using some analytic geometry. Okay, so I'm going to look at this as kind of being our xy axis. Okay. And we're going to use coordinates then to solve this. Okay. And there may be, depending on the other things that you know about, like related rates of change or combined rates, I should say, you may see some stuff pop up here that looks familiar. So the vertices of these triangles intersect the axes on the y-axis at 0, a and 0, b. And 0, a is this one up here, and 0, b would be this one here. Right? Similarly then, on the x-axis, this would intersect at b, 0, and this intersection point would be a, 0. And I'm going to try to color code this here. So this line here, okay, we can talk about, and let me preface this with what I'm really going to look at here is I'm going to write area for 3 different figures. Okay, this figure here ends up being a square. Okay, we're going to take the area of the square eventually. Okay, plus this area is a triangle, and this area is also a triangle. Okay, and so I'm going to do 2 times the area of the triangle. Now, in order to do that, kind of the key here, what I found to be the key was to identify what this point of intersection was. Like, what's that ordered pair? Okay. Now, right now, we don't necessarily know that it's a square, but I think you can see, and we could prove pretty easily that this does have symmetry, and that will pass through a point. That point right there where those 2 lines intersect also will intersect with the line y equals x, making this red quadrilateral a square. All right, anyway, so let's go back to this line here, the one that starts way up here at 0a, comes down to b, 0. And the slope of this line, I'll call it m1, is, well, change in y over change in x. So down a, right b. So down a, right b. Which means that that equation, y1, is negative a over b times x plus a. The y-intercept is a. Okay. The other equation, or the other line here, has a very similar equation. Okay, its slope, call it m2, is negative b over a, down b, right a. And so y2 here is negative b over a times x plus b. Now, to find the intersection, we need to set those equal or substitute. There's other ways to do that, of course, but I'm going to use substitution here to plug in for the y. Okay, so let's see here. So I'll take this equation, I'll plug it in here for y. So negative b over a times x plus b is equal to, oops, negative a over b times x plus a. Okay, and now let's solve that for x, which gets kind of messy. We'll just be kind of clever here. Okay, we're going to multiply through both sides by ab, get rid of our denominators. This becomes negative b squared times x plus ab squared equals negative a squared x plus a squared b. Right. Now, let's get all of our x's together. So a squared x minus b squared x equals, and I'll move the ab squared to the other side as well. Okay. And if we factor this, we get the quantity a squared minus b squared times x. And this is equal to a squared b minus ab squared. Okay, all right, so x is equal to a squared b minus ab squared divided by a squared minus b squared, which that looks really messy, right? But in the top, we have an ab in common. We can factor that out. These with this a minus b. And the bottom, a squared minus b squared, is a plus b times a minus b. And bada bing, bada boom. Makes that a whole lot simpler. ab over a plus b. Whew. That is beautiful. Okay. Now, let's talk about why that's beautiful. Okay. That means that this ordered pair right here is ab over a plus b, comma, ab over a plus b. And given that the other where the other vertices of that square is, the one opposite of that is at 0, 0, we now know that the area of the square is ab over a plus b quantity squared. This expression, by the way, ab over a plus b, is rather helpful. It's the formula for those classic problems. If it takes George 5 hours to paint a fence and it takes Michael 7 hours to paint the same fence, then how long does it take them to paint it together? You take 5 times 7 divided by 5 plus 7. All right, now what about the area of the triangle? Well, area of a triangle is 1/2 base times height. Okay, well, the base here, and I'm just going to look at the one here I'm going to look at the one up here above the square. That base, well, that's the distance from 0 out to that blue point. So that base is ab over a plus b. And then the height here, okay, we're going to have to use subtraction. This whole distance is b, and we know what the distance of the square is. So that height is b minus ab over a plus b. All right, now this first one we're just going to leave as is for now. No sense in trying to multiply that all out. The 2.5 cancel out. That's wonderful. Let's leave that ab over a plus b alone. Let's deal with this one. A common denominator here, a plus b. And so this, if I multiply b times a plus b, I get ab plus b squared. All right. And we'll leave this the same again. And now we're going to do just a little bit of algebra here. So we've got ab over a plus b times. And then here the ab and the ab cancel out because it's subtraction. B squared over a plus b. Oh, this is looking pretty. I'm just going to switch to black here now for everything. ab over a plus b quantity squared. And on top, or plus, on top here we have ab cubed over a plus b quantity squared. You'll notice those denominators are the same, a plus b quantity squared. Okay, and actually, let me rewrite this one instead. Let's write it that way. And squaring everything. All right, So now we've got a squared b squared plus ab cubed over a plus b quantity squared. And we can take out an a and a b squared from the numerator. And when we do that, we get a plus b over a plus b quantity squared. A plus b cancels, leaves us with ab squared over a plus b. Hey, fun, fun, fun.